For 6 months, that compost pile has been sitting behind the shed. For 6 months, it has been the same leaves, the same kitchen scraps, and the same stubborn, cold heap that barely looks any different from the day it was built. Does that sound familiar? Here is what nobody mentions at the garden center. A single handful of a common substance, available for about $3, can turn that exact pile into dark, rich, crumbly compost in under 18 days. Not 6 months, not a year, 18 days. The science behind it was documented decades ago. Then it quietly disappeared from mainstream gardening advice. Today, that science comes back to light along with the one critical mistake that can ruin everything if the dosage is wrong. Stay for the next few minutes. This one is worth it. The real reason most compost piles fail. So what actually goes wrong? Why does a pile that started with the best intentions end up as a soggy mess or a dry, lifeless stack of twigs that refuses to break down? The answer hides in a ratio that most gardeners have never heard of. Every organic material contains two things, carbon and nitrogen. Soil scientists call the balance between them the C to N ratio. Think of carbon as fuel, the energy source. Think of nitrogen as protein, the building block that microorganisms need to grow and reproduce. Dry autumn leaves have a ratio sitting around 60-1, heavy on the fuel, almost no protein. Sawdust is even more extreme at 500-1, and shredded cardboard is roughly 550-1. But the bacteria and fungi doing the actual work of decomposition need something closer to 25-1 or 30-1 to thrive. When a pile is loaded with brown, dry materials and the ratio climbs too high, the microbes simply stall. They have more energy than they can use, but not enough nitrogen to build new cells. They slow down, they stop multiplying, and the pile goes cold and sits there for 8 months, 12 months, or sometimes longer, doing almost nothing. Picture a kitchen stacked with bread, but no meat, no eggs, and no beans. Plenty of calories, zero protein. Nothing grows. Meanwhile, across the planet, roughly 2 billion tons of food waste end up in landfills every year. That waste rots without oxygen, releasing methane, a greenhouse gas about 80 times more potent than carbon dioxide over 20 years. At the same time, gardeners spend billions of dollars on synthetic fertilizers to replace the very nutrients that food waste already contains. The waste being thrown away is the fertilizer being purchased in plastic bags. The irony is staggering. But what if the missing ingredient to fix a stalled compost pile costs less than a cup of coffee? That is exactly where this story goes next. The $3 fix that changes everything. The substance is called urea, a simple organic compound with the chemical formula CH4N2O, and it is one of the most nitrogen-dense materials commercially available. It contains roughly 46% nitrogen by weight. A small bag costs a few dollars at any garden center or hardware store. $3 buys over 3 pounds of pure, concentrated nitrogen. Here is what happens when about 100 to 200 grams of urea, roughly a handful, gets dissolved in water and poured into a cold, carbon-heavy compost pile. That sluggish 60-1 ratio drops straight into the sweet spot of 25-1. Day 1, nothing visible, but the microbes are waking up. Day 2, steam rises from the center of the pile. The bacterial population, suddenly supplied with both fuel and protein, starts doubling at an exponential rate. Their metabolic activity throws off heat. Day 3, a thermometer pushed into the pile reads 130 degrees Fahrenheit, maybe 150, maybe 160. This is the thermophilic phase, the biological furnace of rapid composting. At these temperatures, a completely different class of heat-loving microorganisms takes over, thermophiles. They are aggressive, efficient decomposers, capable of breaking down tough plant fibers that ordinary bacteria cannot touch. At these temperatures, weed seeds get destroyed and harmful pathogens are eliminated. The compost is being sanitized while it breaks down. A pile that would have taken 300 days is now finishing in under 30, a tenfold acceleration triggered by a $3 handful of powder dissolved in a watering can. But before reaching for a bag, there is something important to understand first. This substance has a history, and that history reveals why this knowledge disappeared from common gardening practice. Urea might sound synthetic, but it is not. Every mammal on Earth produces urea naturally as a metabolic waste product. The molecule is identical whether it comes from a laboratory or a living body. In 1828, a German chemist named Friedrich Wöhler became the first person to synthesize urea from inorganic materials, a discovery that shattered the belief that organic molecules required some mystical vital force to exist. That single experiment laid the groundwork for modern biochemistry. But the real agricultural insight came a century later from a man named Sir Albert Howard, often called the father of modern organic farming. Working in Indore, India during the 1920s and 1930s, Howard developed a composting method that relied on precisely this balance of carbon and nitrogen. He did not use bagged urea. He layered animal manures, naturally rich in urea, between plant wastes. His method, published in his 1940 book, An Agricultural Testament, proved that controlled composting could produce rich, finished humus in just a few months. So why did this knowledge fade? Because in the early 1900s, the Haber-Bosch process made it possible to manufacture nitrogen fertilizer from thin air on an industrial scale. Suddenly, synthetic fertilizer was cheap and everywhere. The slow, careful art of building compost lost out to the convenience of tearing open a plastic bag. The consequences show up in the numbers. The United Nations Food and Agriculture Organization estimates that roughly 30% of the world's farmable soil has been degraded, stripped of the organic matter that holds water, supports beneficial fungi, and prevents erosion. The knowledge was never disproven. It simply got buried under convenience. And now, armed with a $3 bag in the same science Howard used a century ago, any gardener can bring it back. But there is a catch, and ignoring it ruins everything. Too much urea, that is the mistake. It sounds simple, and it is, but the consequences are harsh. If the carbon to nitrogen ratio drops below 15:1, the system crashes. Excess nitrogen escapes the pile as ammonia gas, and the backyard fills with a sharp, overwhelming smell. The very nutrient that was just added gets wasted into the air. Worse, temperatures can surge past 160 degrees Fahrenheit. At that extreme heat, even the tough thermophilic bacteria die off. The pile goes sterile, and decomposition stops completely. A white, ashy mold sometimes appears, a signal that the pile is overheated and starved of oxygen. This is where discipline matters. The recipe is straightforward. First, the pile needs enough mass, at least 3 feet wide, 3 feet deep, and 3 feet tall, 1 cubic yard. That volume holds heat effectively. Second, the moisture level should feel like a handful of material that, when squeezed hard, releases just a few drops of water, damp but not dripping. Third, and this is the critical number, use about 1 pound of urea dissolved in water per cubic yard of dry, carbon-heavy material. After applying it, the pile needs active management. These microbes are burning through oxygen fast. Every 2 to 3 days, the pile gets turned, releasing excess heat, letting in fresh air, and keeping the biological furnace running safely and evenly. Get the balance right, and nature does the rest. Get it wrong, and the pile goes silent. That precision and careful attention is what separates composting that actually works from composting that just sits there. Mastering this trick does more than save time on a single batch of compost. A gardener using a few dollars of urea each season can transform hundreds of pounds of yard and kitchen waste into rich, living humus. The kind of soil amendment that would cost a small fortune in bags at the store. That waste stays out of the landfill. No methane, no hauling costs, just dark, crumbly earth ready for the vegetable beds. And the science keeps pushing forward. Researchers at the University of Edinburgh found that adding biochar, a form of stable charcoal, to a urea-amended compost pile reduces ammonia loss by up to 64%. That biochar then persists in the soil for centuries, locking away carbon and creating permanent habitat for beneficial microorganisms. A single teaspoon of healthy finished compost contains over 1 billion bacteria and thousands of different species. Mixed into a garden bed, the teaspoon introduces a whole community of microbial allies, organisms that protect roots, find water during drought, and bring exhausted soil back to life. The forest figured this out long before anyone picked up a shovel. Nature has been cycling life into death and death back into life since the beginning. What gets called a trick is really just paying close enough attention to remember how the process works and giving it a gentle nudge. The next time a pile of fallen leaves or dry garden stalks appears in the yard, look at it differently. That is not waste. That is energy and life waiting for the right key to unlock it. And that key has been sitting on the shelf of the local hardware store the whole time. Tend to the soil, and it tends back. If this story changed the way you look at the waste in your backyard, please subscribe and like the channel. We are digging up the history and science that they tried to bury. Let's cultivate the future together.